Hi folks, this video is going to be about the Jouleringer circuit, and I'm going to be triggering a Jouleringer using a small buzzer. This is a solid state buzzer, and I'm going to modify it so it doesn't make a sound. I've done this in a previous video using an inverter circuit and it worked great, so I thought I'd try it with the Jouleringer. And it's what I've done is I've basically prized the case off the circuit. You just use a screwdriver, it's only glued in. And this is a 6-volt buzzer. And inside we've got a nice little coil which is moving. Well, it's got a magnet with a wiper arm, and that's vibrating in front of a diaphragm which is covered by that black gauze. So to make this quiet, all I'm going to do is remove the diaphragm, and you can do that just by removing it completely or just cutting the plastic membrane off the diaphragm. So that's what I'll do now. Okay, I've removed this black cover here from the top of the membrane, so I'm just going to unscrew these 3 nuts now which hold the membrane on, and we can get it off. There's glue around these, so just chip the glue away with some with a screwdriver. I've done that, and that should come off that now. So that's the membrane off now, and the striker arm. So that just leaves us with the circuit board and the coil now. So hopefully that'll be quiet. Okay, this is the circuit I'm going to be using today. It's the same as I showed in my last Jouleringer video, with the addition of this solid state buzzer here. And today I'm going to be using a BD139. So that's basically it. Now, the load I'm going to be using, it's a 240 volt LED bulb, and it's being driven by the mains at the moment because I want to take a light level reading, and I do that with a little LDR taped to the front of the bulb, and I just take an ohms meter reading, and it's 52.1 ohms, so that's mains brightness. So if I can replicate that reading with the Jouleringer circuit, we're at mains brightness. So I'll switch this bulb over now to the Jouleringer. Right, and the first test I'm going to be using just a resistor. The buzzer is not in the circuit, and I just want to get a base reading with the standard driving technique, which is just a variable pot. So I'll slowly adjust that, and the brightness will increase, and the ohms reading will start coming down. And I'm just adjusting the pot, trying to find a sweet spot, and it's gone past it there. I can't get anywhere near mains brightness with just a resistor, and I'm using 4.5 volts for this test. I think that's about as bright as I can get. 57 ohms. And that's with the standard driving technique. So what I'll do now is I'll swap the modified buzzer into the circuit now and see how we can do with that. Right, so I'll slowly adjust the pot again, and the bulb's getting brighter, and the resistor's coming down with the resistance, and it's completely silent. So we're brighter from the mains now. And basically this buzzer is acting like a pulse width modulation device on the base of the transistor, and it cost I think it was £1.50 for the buzzer, and this is a 6-volt buzzer, forgot to mention that, and this is a 12-volt one. Well, that's a 12-volt one, but you could probably do something similar with a 555 timer setup, but this is just so simple and quick to do. and you can probably use that for something else as well, because it's a lovely little coil in there, and it's a built-in, it's a ready-made pulse device really. And I'll do one more test before I sign off. I'll increase the voltage up to about 12 volts, and obviously the meter reading is it's brighter than the mains now, but if I adjust the pot is on the highest setting, it's on 20k. So if I reduce that now, look how bright I can get it. So I'm seriously overdriving this bulb now. But that's good, because it basically means we can run lots of these in series or in parallel. So that is so much brighter than the mains. So that's basically all I've got for now. Thanks for watching.